Welcome to April, and according to Pete. So thanks for tuning in. Today we are going to talk about how RS-485 works. Are you ready for this? Cool, let's do it. All right, so some high-level stuff about RS-485 before we really dig in. You can get up to 10 megabit per second data rate. You can get up to 1,200 meters distance, but of course, we all know you don't get both of those things at once. You either get a really long distance at a low data rate or a really short distance at a really high data rate. So inverse proportional thing there. It is a multipoint network topology, which is actually to say it is in a linear topology, and we'll talk about that as we go. It has really good noise immunity because it is a balanced differential signal, and we'll talk about that as we go. What it is not a protocol, okay? It is only an electrical standard. Now, some of the protocols that use it are Modbus or Profibus, and I will let you guys look that stuff up. But because the nature of the signal, it's well geared to a serial communication, so like a UART. So what you will have is a RS-485 driver or receiver or transceiver, and it shoots out on RS-485 and you talk to it over a UART. So something as simple as that, all right? Cool. So to start with, RS-485, which is officially TIA 485, in a sec, officially adopted in 1998. Now, RS-485 equals TIA 485 equals EIA 485. And just so we're all on the same page, RS stands for Recommended Standard. TIA stands for Telecommunications Industry Standard? No, Association. I don't know why I keep writing standard. EIA stands for Electronics Industries Alliance. And like I said, it's now officially TIA 485. But everybody still refers to it as RS-485. Why TIA and not EIA? Apparently there was a great war of the Alliance and the Imperial something in the 90s, and they crushed the EIA. So that's the end of that. 485 is the successor to RS-422 from 1994, which is also a balanced line, but it only allows one driver on any given bus, whereas RS-485 allows many, up to 32, and there's some qualifications there. We'll talk about that as we go. Also, I want to mention there is a document out there, a PDF called TBS89A, which is sort of the de facto Bible to setting up an RS-485 network. Some of my material comes from that document. I will post a link in the video description so you can check it out. My own observation as I've gone into this, this is a really good document. It'll tell you a lot of stuff you may not want to know. I think setting up a short run for RS-485 is probably a simpler thing, but if you've got a more complicated network you want to set up, this thing is very, very helpful, and I've got another doc I'll talk about later too. So, what RS-485 is. What I have drawn here is a representation of two transceivers at either end of a linear bus. Now, by linear, we mean a straight line from one end to the other. Not a star configuration, not a ring, straight line, okay? And that's the way this is supposed to go. There are three signals of interest, which is to say an A signal, a B signal, and an SC. SD, I think, stands for signal common, because it's effectively a reference. A and B are differential. Okay, so when A goes high, B goes low. And when A goes low, B goes high. That's how that works. And the receiver reads that at a sensitivity of officially 200 plus and minus 200 millivolts. So when these things separate, now I take that to read, and I'll explain this as we go, but I take that to mean that you have to get 400 millivolts total differential. Somebody might correct me on that, but the way I've looked at this, and I'll explain this as I go, looks like that's the window, which is fairly sensitive. Now, the physical medium this actually takes is like a twisted pair with a shield, okay? And so it's a transmission line, it has a characteristic impedance, and that characteristic impedance is 120 ohms. So oftentimes what you will see at either end of these things is a terminating resistor to the tune of 120 ohms. Cool? Cool. Now, the two inputs can take a common mode voltage with respect to the reference of plus 12 volts or minus 7 volts. So anywhere in that range, these things can be communicating, and the input is going to disregard that because, again, differential, that's what it's looking for. So because this is differential and because of the common mode rejection, this has really good noise immunity in a noisy environment, which is good for industrial applications, right? So if you've got something that's going to happen in a noisy place that you don't think RF is going to penetrate, this is a pretty good option to look at. And it's very common as well. Let's see, covered that. Bus is linear. Oh, it's worth a mention, and it's in my list of things to mention, that, of course, you can add more nodes to this. So let's say this is a really long bus. You can add like another transceiver at another location, okay? But there are rules about this, and again, that document that I referred to, TBS 89A, I think it was, it will detail all the methods of putting these together. And it says right out, star configuration is not recommended, so don't do that. So the rule about this is that you have to have any nodes in between at very close proximity, physically very close proximity to this linear bus. You can't have it shooting off a couple of feet. Why? Because this is a transmission line. The more you jack with that characteristic impedance, the less functional it's going to become. You'll start getting reflections, you'll get data corruption, yada, yada, yada. If you do need to offshoot to a farther location, they recommend putting a repeater circuit right in there so as to keep this one intact and that one will have its own. Kind of like that. Let's see. Receivers, and I'll kind of wrap this up with transceivers at the end. The receiver function has to have greater than 12K of resistance, all right? Take that for a second. A transmitter has to be able to deliver 1.5 volts differential into 54 ohms. Now, also, the spec says you can have up to 32 unit loads. Now, 54 ohms comes from 32 12K loads in parallel with the two 120 ohm termination resistors, okay? That's why the transmitter has to be able to drive at least that much. And that's why the receiver has to be greater than 12K. It's to allow that number. Now, more modern devices have much greater than this, so you'll see advertisements saying, you're gonna have like a zillion transceivers on the bus. So just something to keep in mind when you go shopping for parts. Speaking of parts, transceivers. These guys are in the $1 to $2 range, and 5-volt parts are common. So keep that in mind. As far as the transceivers go, yeah, you have the A and the B, and then you have like receive enable or data enable. You have a data in and a receive out, so it's particularly geared to serial transmission. Now, as an example of what the waveform actually looks like, really simple. When A goes low, B will go high, and that's registered as a 0. And when B goes high and A goes low, that's registered as a 1. Now, I didn't write a whole byte or a whole data frame. The transceiver is going to put out whatever you give it at data in, as long as it's enabled to do so. So really, this is the critical information. This is differential, and this is how the numbers are read. Now, something about this, and I'll explain this as I go, as I always do. 200 millivolts plus and minus sensitivity. Now, the reason I'm questioning that is because of an example that was given on Wikipedia. And let me back up a sec. When all of the transceivers are in receive mode, which is effectively high Z, right? These two lines have to be fairly stable, relatively speaking. I mean, we did say this is a very noise immune system, and it is, but you have to hold them at known values so that you don't get accidental data reads, or you know what I'm saying? And so what you often see, and this is the example that I'm taking from Wikipedia, is a bias network where you've actually got, let's see, we'll call that VCC, and then another one to ground. And the example that they give is 130 ohms there, 720 there, and 720 here. Now, if you do the math, 130 in parallel with 1440, that will give you about 119 ohms. So the characteristic impedance is still maintained. But what you end up with is a forced separation of the signals A and B, okay? Now, my problem with this is that if this is a 5-volt source, that's the worst 5, it looks like an 8, Pete. What you will get out of this is 414 millivolts separation between A and B. And so I look at that and I go, okay, that's kind of over the threshold of registering a 1 or a 0, right? In this case, it would be a 1 because you're holding A high and B low. So my guess is that these values are infinitely tweakable, well, as long as you're maintaining 120 ohms, and the separation that you're maintaining becomes something very specific to your transceiver choice or your network topology, et cetera, et cetera. So I'm taking these values with a grain of salt, but oftentimes what you see is this bias network to hold these lines at known values so you don't get corrupt data. Now, there's another tutorial that I'm going to refer to you at the end, and I'll include a link in the video description that is written by Renaissance, and it's a good tutorial. They do favor intersil parts, which is fine, but in it you will read like some parts are able to account for all of the biasing and yada 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 without the addition of the resistors. I'm not certain how common that is, but it's seemingly available. So whether or not you're setting up a bias network is going to depend on your choice of transceivers. Let's see. And the reason, yeah, so I talked about that 200 millivolt sensitivity, bias network. I think that's everything. This really isn't a difficult bus to wrap your head around, right? But that's it in essence, I think. Unless I missed something. If I've missed something, somebody's gonna pipe up and say, oh dude, I've been doing this for 20 years and you've missed this. I guarantee you I have. But that's the essence of the bus. So that's it. That might be a record short ATP. I'm not sure. I guess I won't find out until we get the video back. Now, if you want to go further, learn more about it, like I said, there's a document. I will put links to these things in the video description, so you can just plug them right in. TBS 89A is the de facto how to set up an RS-485 document. There's also this Renaissance tutorial. Again, they favor intersil parts, but not glaringly so. I mean, they wrote the tutorial. They should be able to drop their name once or twice. All right, fine. But there's a lot of good information in it, so I'm going to give you that one as well. And that's it. If you've got any questions about RS-485 or any RS-485 war stories, post them in the comment section. We'll talk about it. We'll laugh, we'll joke, we'll have a great time. So, until next time I see ya, bye. $32K, I don't know why. I do this all over again because it's just, next frame. Because, how am I gonna say this? You know what, I gotta do this again. Let's see if I can do this any better this time. Ready? Yes. Okay.